Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about design patterns. What are design patterns? Why one should use it? Why they have been in implementation? Everything we are going to discuss about design pattern in this video. And later on in upcoming videos, we are going to discuss how we can implement it out in our applications. So this is the series of design patterns. One by one, we'll discuss all the design pattern with the practical implementation of it. So let's get started for that. Here in this video, we are going to only discuss about the design pattern, what it is, what are its advantage, disadvantage, what are the different type of design pattern we have, and how we can implement it out. So this is what we are going to discuss in this video. Let's get started for that. So the first thing is, what is design pattern? Okay, design patterns are proven solution. So you can see that it is a proven solution to common problems in software design. So when in the earlier days when the development was going on, there were common problems in the software development, and to remove those problems, to solve those problems, we have invented the design patterns. Okay, so they are the proven solution to common problems in software design. They provide a template for writing codes that is reusable, maintainable, and scalable. So design patterns are the templates for writing codes that are reusable, maintainable, and scalable. Okay. Here is an overview of some common design patterns categorized by the type and how you can start learning and implementing them in Java and Spring Boot. So you can see that the design patterns are broadly classified into three different categories like creational patterns, structural patterns, and behavioral patterns. Okay. So coming to the creational patterns, we have so many design patterns here. And the creational design patterns basically deal with the object creation mechanism. Okay. So we have singleton, we have the factory, we have abstract factory, we have builder, and we have prototype. These are the 5 main creational design patterns. Make sure when you remember the creational design pattern, remember that they deals with the object creation mechanism. So when we have someone asking about the creational design patterns, we are aware that the creational design patterns deal with the object creation mechanism. Okay. Now there are 5 different creational design patterns we have listed here, which is singleton, factory, abstract factory, builder, and prototype. In the singleton design patterns ensure only one instance of a class exists and provide a global access point. So let me give you an example. When you try to have let's say you are going to develop a Spring Boot application, you are going to develop a API, and there you have developed some service layer, repository layer, entity, and the controller, right? When the controller is going to call the service method, we have the service layer, right? And in the service layer, the classes that we are going to create for the service implementation, they are annotated with @service annotation. That service annotation is creating a single object of that particular class, service class, or service implementation class, and assigning it to the application context. And that is why wherever we need that object, we auto add the service instance and we get it out. How we do in the controller class to call the service method, right? So this is one of the example of singleton design patterns where it makes sure that only one instance of the class or only one object of that class is created, and it provide a global access point. Example here I am giving is Spring Bean with the scope @scope singleton. So when you are going to define the scope of a bean as singleton, that means only one object of that particular class will be created, and it will assign to the application context, and then from there everywhere we can access it out. Okay, so this is one of the design pattern, creational design pattern, which is singleton, and it is very much popular, and it is being asked in the interviews repeatedly. So make sure you have an idea of it. In the coming videos, we are going to discuss all the design patterns one by one with a practical implementation of it, its advantage, disadvantage, everything we are going to discuss. Now coming to the second design pattern, which is factory method. Okay, it defines an interface for creating an object, but lets subclass decide which class to instantiate. So here what we are going to do is it will try to give you an abstraction. It will try to do a loose coupling for the creation of the object. Okay, so it defines an interface for creating an object, but lets its subclasses decide which class to instantiate. Okay, so this is factory design patterns. When I'm going to implement it out, I will show you everything in detail. Example, here we have the factory to create different type of database connection. So let's say in your application you are working with 3 or 4 different databases. So we have a common abstract class, and we have subclasses which is implementing that connection abstract class. Okay, so that is what we are mentioning here. That is what the factory design pattern is. Okay, and at the runtime we can create the object of particular class, database class, which is needed. That is where it defines an interface for creating an object, but lets subclasses decide which class to instantiate. Okay, now coming to the third creational design pattern, which is abstract factory. It is similar to the factory design pattern, but there is a one more layer of abstraction is included here. Okay, so it provides an interface for creating families of related object. Make sure that it is not creating the object itself. It provides an interface for creating family of related objects. Example, a factory to create UI components like button and drop downs for multiple platforms. So let's say you have a platform Mac and OS, and there is a you have to design a UI component for that, and you have buttons and drop downs. So you have a separate buttons, separate drop downs for Mac and OS. So that is where it is telling that it provides an interface for creating families of related objects. Okay, so this is what factory design pattern is. When we are going to implement it out, you will get the better idea of it. Coming to the builder, allow step-by-step construction of a complex object. Example, building complex response entity in a Spring REST controller. So this is the builder is allowing step-by-step construction of complex object. So let's say you have a complex object that need to be created. Then the builder is allows step-by-step construction of complex object for you. Coming to the fifth one, which is prototype. It creates a duplicate object by cloning. Example, using the clonable interface for a prototype registry. So these are the 5 different creational design patterns we have listed, and they are mainly popular here. So make sure you remember them. Coming to the next slide, we have the structural design patterns. These design patterns deals with the class and object composition. What are the composition of class and object? That is what it deals with. Here we have different structural design patterns like adapter, decorator, proxy, facade, composite, and bridge. So these are the 6 different structural design patterns we have listed here. Coming to the adapter, it allows incompatible interface to work together. So we have 2 different interfaces which are not compatible. Then you can use the structural design pattern adapter to work with them. Example, adapting a legacy system output to work with a modern API. How we are going to do it, I will show you in the later videos. Coming to the decorator, it adds behavior to object dynamically. Example, customizing a handler interceptor in Spring Boot. So if you don't know what is handler interceptor, there is a video on my channel where I have discussed about the interceptor in the Spring Boot, and we have implemented it out. So you will get the idea of it, what it is. So it adds behavior to your object dynamically. Okay, which is decorator. Coming to the proxy, it control access to an object. Example, Spring AOP proxy for logging and caching. Coming to the fourth one, which is facade, provides a simplified interface to a complex system. It provides a simplified interface to a complex system. Example, a service class in a Spring Boot that encapsulate multiple DAO class. So if you have implemented the service classes or DAO, or you can say repositories, entities, the controllers, then you will come and understand it out. A service class in Spring Boot encapsulates multiple DAO class, right? That is what the facade is. It provides a simplified interface for a complex system. Compose it. Com- it it composes object into three structures. Okay, example representing hierarchical data like categories in a product catalog. Now the sixth one is bridge. It decouples abstraction from implementation. Okay, example separating service logic from data sources. So these are the six different structural design patterns, and in the coming videos we are going to discuss one by one each of them with the practical implementation of it. Coming to the third design pattern, which is behavioral design pattern. This design pattern focuses on communication between objects, how one object communicate with the others. That is what the main focus of behavioral design pattern. There are different kind of design patterns I have listed here, which is such as strategy, observer, command, template method, chain of responsibility, state, mediator, iterator. Okay, coming from the first one, strategy, it defines a family of algorithm and let you select one at a time. Example, multiple payment processors Razor Pay or Stripe in a Spring Boot. So let's say you have a different kind of payment processor interfaces developed. Now, how you can choose one at the time of payment? That is what is being implemented using this strategy. It defines a family of algorithm and let you select one at a time, one at runtime. Now, observer notifies multiple objects when a state changes. Like event, you have if you have come across the event-driven architectures, there we have this scenario. Or you can say, let's say you implemented the Kafka or RabbitMQ or ActiveMQ, then you come across this scenario. Okay, so event listener in Spring's application event publishers are example of it. Coming to the third one, which is command, encapsulate a request as an object. Example, executing scheduled task. The fourth one is template method, defines a skeleton of an algorithm in a base class but allows subclasses to provide steps to override steps. Example, abstract service layer implementation. Chain of responsibility. I'm just covering it fast so that we can wind up this video. But in the coming videos, we are going to discuss each design patterns in details with the practical implementation of it. So we'll get the more idea of it. Now coming to the next one, which is chain of responsibility. Passes request along a chain of handlers. Example, Spring security filters. Coming to the next one, which is state, allows an object to alter its behavior when its internal state changes. Example, order states new processing on completed. Coming to the next one, which is mediator, encapsulate how object interacts. Example, Spring dispatch servlet. Coming to the last one, which is iterator, provide a way to access element of a collection sequentially. Example, custom pagination for large data sets. So these are the three different categories of design patterns, and inside those design pattern categories, we have discussed multiple design patterns. Coming to how to learn and implement it out, first you have to do is you have to understand the problems, identify scenario where a pattern could simplify or improve your design, which design patterns is best suited for your problem, that you have to do, and then you have to implement it out. So first you have to understand the problem, choose one of the design patterns and then implement it. Learn with example. Start with the basic example and incrementally work on more complex ones. Use Java Spring Boot to implement them. So try to develop a mini project and then try to see how it can be implemented, and then go to the real project and implement it out. Build mini project, create a small project focusing on one pattern at a time. Apply in the real project, identify opportunity in your ongoing project to use these patterns. Now, the fifth step is refactor existing code, replace ad hoc implementation with the proper design pattern. So these are the things that you need to learn. How we like these things you have to keep in mind when you are going to implement the design patterns. So this is about it. Now in the coming videos we are going to discuss about the singleton and with the practical implementation, we'll see how we can implement it out. So this is about the design pattern introduction video. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.